Good morning, cybersecurity professionals, enthusiasts, and all those in between. I'm Chris Callis, and today we're going to be diving deep into the world of automated defenses. Particularly, we're going to be covering HijackLoader, a malware loader that acts as a modular tool that enables delivery of additional payloads and capabilities. Then, we're going to discuss the MITRE attack framework and how we leverage it to perform counter-adversary operations, allowing us to test our security tooling, ensuring our organization is capable of identifying and responding to emerging threats. Then we're going to take a look at our TINE's automation capability matrix and how it helps us understand how we have implemented automation into our security operations. Finally, we're going to take a look at all this information and not just perform a theoretical tabletop exercise. We're going to stress test our controls by simulating adversarial behavior using a combination of Atomic Red Team, Crowdstrike, TINEs, and Jira to respond to suspected behavior. And this allows us to kind of showcase our security program has adopted a systematic, risk-based approach to security. We got a lot to cover today. Let's go. At the heart of a growing number of attacks lie the malware loader, such as HijackLoader. Their primary function, to load and execute malicious payloads without detection. This is essentially a first-stage payloader with a whole bunch of advanced capabilities. Its goal is to get a foothold undetected and support the delivery of an adversary's desired payloads. Its architecture not only allows for the effortless integration of new features, but also includes a wide range of dynamic anti-analysis techniques. HijackLoader is a new breed of these advanced threats, where adversaries have adopted DevOps methodologies equipped with real-time update capabilities that can easily circumvent modern security controls. Its complex payload delivery mechanisms and evasion techniques pose significant challenges to existing security operations center strategies. For more on this, you could check out some of the research that we've done on our website. More details are down in the show notes. So as traditional defenses continue to prove inadequate, the swift proliferation of HijackLoader underscores the immediate necessity for advanced detection and response solutions. These loaders are sophisticated, they evade detection, exploit vulnerabilities, and pave way for further intrusion by delivering payloads that range from ransomware to spyware. Once inside a network, HijackLoader initiates its operations by executing modified Windows C runtime functions. This allows it to inject and execute adaptable code through its embedded components. During its initialization phase, the malware loader downloads an encrypted configuration block, which is then decrypted using bitwise operations. These configuration blocks have been found to differ from sample to sample, indicating a level of adaptability. HijackLoader employs a series of anti-analysis countermeasures that further complicate its detection. These include leveraging dynamic Windows API functions and custom API hashing techniques. And the malware also performs various connectivity tests and adapts its behavior based on the presence of specific endpoint protection solutions. To ensure its continued operation within compromised networks, HijackLoader employs several tactics for persistence. These include creating shortcut link files within the app data folder and generating random event variables leveraged later on. Recognizing the signs of a loader at work is paramount to preemptive defense strategies. To plan and combat these threats, we turn to a structured approach using MITRE attack. ATT&CK is a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. The ATT&CK framework is our playbook for understanding and addressing adversarial behaviors. Using ATT&CK, we could simulate the actions of an adversary, such as HijackLoader. This allows us to test our defense understandings, potential vulnerabilities, and tailor our responses appropriately. MITRE attack helps teams understand how adversaries penetrate, move laterally, and evade defenses. So prior to this stream, we took some public data and the research that we've already done on HijackLoader and mapped its TTPs within MITRE attack. So under execution, we can see that there's native API. And as I'm going through this, I like to kind of keep some of the stuff in the back of my mind as we get into our next section and actually picking the different payloads that we want to simulate. So first we have native APIs under execution, and then we know it involves user execution, leveraging a malicious file, that there's privilege escalation behaviors take place over process injection. It's defensive evasion. Tactics include deobfuscation and decoding of files of information, steps to impair defenses, likes to obfuscate files or information as it's performing its anti-analysis techniques. It leverages dynamic API resolution. Under discovery, it also does some network discovery, wanting to understand, hey, is there an actual internet connection? There's also process injection, where it leverages some doppelganging and process hollowing techniques. And it also performs a bit of reflective code loading. Before we go further, we need to discuss the tooling that we're going to be leveraging today. First, Crowdstrike. I don't know if I'm going to stick a logo up or anything like that, or if you even know how. I'll figure it out. Enter Crowdstrike. It's a cornerstone in our cybersecurity defense arsenal. Crowdstrike Falcon platform excels in detecting and mitigating threats in real time by leveraging next-gen antivirus, endpoint detection and response, and 24/7 threat hunting service. With CrowdStrike, when a threat like a malware loader is detected, the information is instantly analyzed, giving us insights needed to respond swiftly. It's not just about detecting the threat, it's about understanding the context, the severity, and the best course of action to neutralize it. Next up, Slack and Jira kind of go hand in hand. Slack is going to be used for chat ops. I'm personally a big fan of this. It's a collaboration model that connects people, tools, process, and automation into building a transparent workflow. Repeatability is vital. And Jira is going to be our single source of truth for tracking cybersecurity alerts and events. This is crucial for a SOC with many different analysts and engineers across multiple specialties and shifts need to interact. This is going to provide the current status of any security incident and allows for teams to dramatically reduce the blast radius of an issue. And Tines. Full disclosure, we're a SaaS partner reseller with Tines. That being said, they've had no involvement in this video. They're not paying me for this content, and I don't think they have any idea that I'm actually doing this. Those that know me know that I'm a fan of being able to codify a process, because after I personally complete something, I'm going to drop all knowledge of it and move on to the next thing. And when I come back, nothing's worse than having to spin back up, remember the bookmarks, try to figure out where I actually took notes, those type of things. Before we jump into the Tines story, which are the actions that we're going to be taking today, let's take a look at our Tines automation capability matrix. Automation is the natural progression for a SOC team, but deciding how and when to implement it is pretty challenging. The matrix allows security teams to proactively respond and tackle common cybersecurity incidents, and this allows organizations to build that muscle memory that's needed on how to respond to some of the most crucial events that you're going to be experiencing. The framework reads from left to right and top to bottom within categories, and it's minimally opinionated and adaptable to what your unique organization finds most valuable. So let's take a look at some of the capabilities that we're going to be working through today. We already talked about how we're going to be leveraging CrowdStrike to look at CrowdStrike alerts. And within each of these descriptions, you can see it goes over what's actually occurring, why monitoring for endpoint alerts are important, some of the techniques that we've implemented in terms of being able to retrieve new CrowdStrike alerts and centralize the alerts to Jira and enable workflows within Slack for chat ops. We have some future state planned activity, and that'll be escalating it up to the next tier, performing forensics, as well as scans after remediation. And I've started also, this doesn't come with the matrix, but I started mapping this out in terms of what CIS controls are relevant, which PCI controls are relevant, and also which NIST CSF 2.0 subcategories are aligned with the actions that we're actually taking. That's something I'm going to continue to build out here. Next is issue tracking. In terms of tracking location, we already talked about how it's important to have a single source of truth and what techniques we currently have available with this workflow. So creating tickets within Jira, adding actual comments to those tickets, and we'll evolve that later on. Next one we have is issue deduplication. This is huge. You don't want to have the same ticket opened up like 100 times as CrowdStrike is going through its analysis. So we do have deduplication capability, and we'll be taking a look at that once we dive into the Tines platform itself, and have the ability to actually close tickets if it's a false positive, or no remediation steps are actually needed. We also have enrichment functions. We'll dive into this a little bit again as we're looking at Tines. One of the things that the workflow does do is it'll submit the hash information over to virus total. Some of the future techniques that we're going to be doing is sending it off to like hybrid analysis or some type of like sandboxing features to perform forensics. We don't have that built out right now, but if that is something that you're interested in seeing more of, just definitely hit the subscribe button, leave a comment below for what you would like us to further expand on. And the ability to do an issue closure. What else do we have here? We talked about file analysis, domain analysis, IP analysis, user lookup in terms of governance and the program itself. We already implemented chat alerts and have some functionality in terms of security team responses, chat events. And for today, we have the capability to do host isolation. We'll get into that during the actual simulations themselves. Anyways, I marked them kind of purple here, as you can see, for things that we do have in place. So the whole idea is, hey, here's the most common type of alerts and just build out these capabilities based on what's important for us. This is the Tines platform itself. We're taking a look at the Analyze CrowdStrike Detection story. What's really cool about Tines is there is a library. So this started off as, I think they called it Analyze CrowdStrike Detections, and I kind of modified it to kind of fit, our use case. So what happens here is there is a webhook that goes out to CrowdStrike and pulls some recent detections. And if you haven't seen the Titans platform before, when you go into events, you could see the results of those detections, body, resources, and you could see the events that actually came through. And then what's going to happen is it gets detection details off of those events themselves. So we go body, resources, and we could see that it broke out the events into individual detections. It's going to explode the detection. So it's going to break those out individually. It performs a deduplication. That way we don't keep on getting the same thing over and over every time it runs. So right here for the testing itself, we're going to be manually hitting run. Deduplicate events. It's going to fetch the Crowdstrike URL. That's going to be used for our chat ops. Again, it's going to take the hashes that are provided via Crowdstrike, send them off to VirusTotal, and then it starts building the behavior. So that's where it's essentially the contents of the ticket. Then it's going to throttle the event, allowing things to start catching up. Then the next step is it's going to search issues within Jira. The way that it does this is kind of neat. The Jira identifier, this is how it knows, do I need to create another ticket based on the event? Right now, it's just based on the host name itself. So it's going to search for those tickets. If it does exist, going to add it to the ticket. And if it doesn't exist, it's going to create the ticket. Then it's going to post a message to Slack. And then right here, we have a couple capabilities from Slack versus, hey, we want to see the Jira ticket, close the Jira ticket. We also want to have the ability to contain it and then escalate it further up the chain for further analysis. And that is essentially a Titans flow in a nutshell. So we're finally here. We're going to be using Atomic Red Team. A lot of people point out, I don't know if that actually does anything. I'm going to try to stick a logo there, but also want to get this video out. So we'll see how it goes. Anyway, so just a high level. And again, if you want to see more of this, just leave a comment below. Atomic Red Team is a library from Red Canary, and it contains a library of tests which are mapped to MITRE ATT&CK. These tests are small, they're portable, and they enable security teams to reproduce threats to test their security controls. Now, the library is great, but you also need a framework to execute against those tests. For this, we're going to be using Invoke Atomic Red Team. There's other things out there. This is just going to be some basic usage. One of the future videos, we want to take a look at maybe MITRE Caldera, kind of take it from there. But really, as you're kind of building out those adversary behaviors, you do want to mimic how they work in real life, and we're going to kind of go through that right now. The first one we have is T1204, subtechnique 2002, user execution, malicious file. So we know that, the samples that exist, there's a backdoored version of something like streamingclient.exe. It gets inadvertently downloaded, and it acts as an entry point to redirect to a malicious stub. So as you kind of go through these tests here within the Red Team, there's two of them that I'm going to pick. It's going to be the OS tap, the number 2, payload download. And the other one I'm going to do is a link payload download. I just remember in some of our previous research, there was some link behavior that was actually occurring. So I wanted to make sure that we cover these. So what does it look like to actually be able to test? Invoke Atomic Red Team T1204002, tests 2 and 10. And the next thing, first we're going to do is show details brief. We could see that they are available. Next, what we're going to do is we're going to check prereqs. And we see that we have the prerequisites met. There's a function in here, and some of these, because I'm on a clean VM right now, the prereqs won't be in place, so we'll do get prereqs. But for right now, we just want to run the test. We see the Crowdstrike Falcon sensor kicked off. The process was actually blocked. Perfect. And that's kind of like what we're going through at the moment. So we see that it was blocked via Crowdstrike, and that's kind of like what we want to see. What we're going for is, hey, what are things that actually do not get stopped? T1027, obfuscated file or information, dynamic API resolution. And so this is where HijackLoader in its stages hides some of the important information about itself by dynamically retrieving kernel 32 and NTDLL API addresses. And it does this by parsing and retrieving address functions. So what we're going to do here is the same thing that we did before. We're going to do invoke Atomic Red Team. It's number 7, and we're going to do show details brief. And this lists the tests that are available. With this one, it's just 1. And keep on deleting the 7. And what we're going to do here is check prereqs. Yeah, and we see that prereqs are in place. So let's go ahead and let's kick this off. T1016 System Network Discovery. And with System Network Discovery, the one that I picked out here connects to our remote server to check if is the machine connected to the internet using WinHTTP API. I'm using test number 7, Quackbot Recon. Check prereqs. Yep, we see it's there, so let's kick this off. It's running nice and smooth. So as that's running in the background, we'll just kind of move on. So deobfuscation and decode of files. This one we did tests 1 and 10 for it, just because it uses some Zor mechanisms to decrypt the download stage. And then it also uses some compression during the download stage. So number 1 test is deobfuscate, decode files of information, and number 10 is Zor decoding. So just wanted to see if we had those capabilities. Next one that we're going to be doing, we haven't done the deobfuscation, decoding of files yet. So let's get this in here. Check prereqs. Both are in there. Some of them don't have the prereqs, I think. I don't know. It's been a couple days since I've ran this. Perfect. We see Crowdstrike blocking processes because of malicious behavior. Next one that we have here is T1027, obfuscate file or information. And we're going to be doing, this is where HijackLoader drops the Zor encrypted file into app data subfolders to store for future stages. We're going to do test number 4, which is execution from a compressed encrypted file, and number 9, snake malware encrypted CRM log file. All right, so let's get to it. Cool. I thought OBS may not have been recording, so that would have been fun. Okay, so this is one where we see the prereqs are not met. It says this needs to be on the disk, so let's see if we can just do get prereqs. Yeah, so now we have the prereqs for at least number 9, so let's do number 9. Next thing that they do is reflective code loading. This is number 1620. There's only a single test where it's WinPwn. It reflects loads Mimikatz into memory itself. So let's clear this out. See if there's any prereqs that we need. It's good. Let's run it. And we see the process was blocked via Crowdstrike, which is good. Next one is going to be 1106 native API. We're going to be doing test 1, execution through API create process, because we know that it uses direct syscalls and a whole bunch of APIs to perform bypasses and injections. Ready to roll. Yeah, looks like I would have opened up the calculator. Interesting, interesting. Okay, let's keep on moving on. We'll kind of analyze this here in just a little bit. Next thing we're going to do is move on to, we have 2 more tests, T15620 and pair defenses, disable or modify. For this one, so it goes through similar stages to another malware loader called Heaven's Gate, and it likes to remap some x64 NTDLLs to bypass user space hooks. So the big one I'm going to go through here is, I'd probably spend more time picking up some stuff, but these take a little bit longer to load. So I'm going to see if we could get it to uninstall Crowdstrike Falcon on Windows itself. So can we check? Oh, got it. It's T1562. .001. Perfect. Let's run it. And the next one is T1055-12. This is where it does process hollowing and doppelganging techniques. This stage is it implements a process hollowing technique variation and it ejects command.exe and login agents. And also the shellcode implements a process doppelganging technique variation to load the final stage into logagent.exe. So this one we're going to be running test 2, 5, and 10. So 2 is remote process injection and LSASS via Mimikatz. 2, 5 is read, write, execute process injection, and 10 is remote process injection with Go using the Win API natively. So we need the Mimikatz executor and PS exec. Let's see if we can get prereqs. No, they're all there now. Perfect. So let's run this. We see some pop-ups actually occurring. Got this one, Atomic Red Team. We see that it was able to open up Notepad, access denied, found some vulnerable DLL address space. And again, we'll kind of run through this a little bit more in the future. But that is the actual testing done. The last thing that we want to do is make sure that we clean up everything and probably roll back the VM. So we do that with the flag cleanup. So I'm just going to work backwards here. Clean up. Next one is 1106. Because otherwise the alerts just keep on keeping on. Don't know if there was any, forgetting the name of the game. Keep on keeping on. 207. Yep, and that should be all of it. All right. Testing is complete. Let's see what we got. All right, now we're back. We've given Tines a couple of minutes to run. It's gone through its first loading itself. So a reminder, we do have it set to run every 5 minutes. We can see if we take a look at the events, the last thing they picked up was 5 minutes ago, and it did pick up some body resources. Yep, and we have another one kicking off right now. So you can kind of see what it looks like as it's running. You'll see that it starts spinning. It started going through deduplication of actual behaviors. Did it deduplicate? True. And then what's going to happen is it'll start grabbing Crowdstrike URLs, running things through VirusTotal. And it's just going to work its way through the stack and start adding details. This is what we see within Slack here. We see that a new Jira issue has been opened based on a Crowdstrike detection. We get the severity. This is its max severity, the Jira ID. We'll enrich it with more stuff. For this, I just wanted to focus on being able to take some actions. So first thing we could do is we can view the event within Crowdstrike Falcon itself that we've been running, the huge different process tree. So a whole bunch of stuff's going to be coming through. So we could see some of the Mimikat stuff that we kicked off is actually being ran within Crowdstrike. The next thing we could do is we could take a look at the Jira ticket itself that got opened up. We get to see the tactic and technique. So we could use that to go back and map it to the MITRE attack work that we were actually doing. Attacker methodology. It'll show you IOC sources. We also get the VirusTotal scores and when things were actually ran, and descriptions what was actually going on. The next thing we can do is we're able to close Jira if we determine that it's a false positive. And we could also take steps to contain the device. All right, so it's letting us know that based on the filtering that it was done, adding additional details to the Jira incident so we could see the initial behavior that we have. And we can see that it's behavior 3 of 57. This is 1 of 57. You can see that there's different tests. This one's 1055, the check prereqs. This one is show details on 5162. As things are going through, we see that Tines is adding detection information to the ticket. In the next video, what we're going to do is we're going to escalate it. But for right now, we just want to contain the device. So we're going to hit contain the device. And within the ticket, we should see device has been contained. Yeah. We see that it is network contained right now. So perfect. In our future video, we're going to escalate it to do some forensics on the system itself and see what the next stage would look like. For right now, I guess we could close the ticket too. See, Tine says, thank you, it's been closed. In the next video, again, we'll go through the escalation process, spinning up a isolated environment with AWS and performing some forensics. So understanding malware loaders and leveraging insights from MITRE attack framework and employing powerful tools like Crowdstrike are fundamental steps in our cybersecurity journey. Each component plays a vital role in our overarching strategy to detect, analyze, and neutralize threats before they can execute their malicious intent. During our next segment, we're going to escalate to a CERT team. We're going to go through the malware analysis process and conclude the investigation. So make sure you subscribe to get notified when that video is up and leave a comment for anything that you would like us to see dive more in depth on. Till then, stay safe and I'll see you around. Have a good day.